All right, everyone, going through the Linux command line interface cryptography labs. First thing, I am in my Google Cloud shell, so console.cloud.google.com. I happen to have it turned on with the additional features in my account, but you can just go to your personal account if you don't want to figure that out on your own, or it doesn't work on your hawaii.edu account. But anyway, so here I am. I'm at a Google Cloud shell. I'm not going to go through the clicking part. You can figure it out. Basically, you go to Google Cloud shell and you go ahead and launch a terminal. So that's that little box right there, launching a terminal. So I'm going to come over here, and first thing I'm going to do is I'm going to do a quick ls. And you see there's nothing except a README file, which we could look at, but I want to install a program called tree. It says it's not there, so I'm going to go sudo apt install tree. Tree gives you a visual. It gives you a visual of what your file structure is in a particular area. Also, I'm going to do some aliases. C equals clear, because I don't like to type a lot of stuff. I'm going to go alias L equals, and then single quote ls tac a LH, which stands for list with the options of A for all, including hidden files, L for long, and H for human readable. And then if I click L now, it shows you all this other stuff. So previously it just showed you, where was it? So much fun reading it. Okay. It just showed you there was a README file. Right now, if you do the ls tac ALH, or AHL, doesn't matter. You get to see all the hidden files as well as that text file. Then I'm also going to do alias T equals tree, and I'm going to go C for clear, and then I come up here, hit T, and notice it just shows me from the root directory. The dot is just that one file. It doesn't show you all the hidden ones, but that's quite all right. Okay, so now I'm just going to look at some instructions I wanted to do in here. I want to create a folder called files, so make dir files. Now if I tree it, you'll see I have a files directory. So I'm going to cd F, and I hit tab, it goes straight to files because it's the only thing that's in there with an F. And if I tree now, there's nothing in it, right? So let me go ahead and clear. And what I want to do is I want to create a file. I'm just going to call it file.txt. So I'm going to go echo, here are some words. And then I'm going to send that over. I'm going to rewrite or overwrite a file called file.txt. It doesn't exist, so it's just going to create one. Now, if I tree it, I'll see that right there. And if I go cd, which goes cd tilde, which goes back to my root directory, and I tree now, you'll see I have files directory and file.txt subdirectory. So I'm going to go ahead and clear cd files, and I'm in the files directory, and then I'm going to ls, and I've got my file.txt. Okay. And if I want to see what's in it, I can go cat file.txt. Here are some words. Wonderful. Okay. So now let us go through the rest of the instructions. What we're going to do is we're going to create a hash, 3 different hashes, 3 different sizes of this file.txt. So if we go md5 sum of file.txt, you'll see there's that output right there. It'll give you this output, which I think is 128 bits, and don't quote me on that, but it's hexadecimal hash code for it. Then I'm going to do a SHA-1 sum of file.txt, and notice that it's longer. I think this is 180, 160 maybe. Let's go 128, 160 bits. Don't quote me on that. Forgot off the top of my head, but one I can tell you for sure, SHA-256 sum of file text will be 256 bits, and you'll notice that it is considerably longer for the hash of that particular file. So now remember, hashes are non-reversible. Okay, everything's great. Now what I'm going to do is I want to use this hashing feature and test whether files are the same if something changes. And if I change just one, if I add one character to the file, does it do anything of significance, right? So let me go ahead and hit the copy command, and I'm going to go file.txt, and I'm going to go file1.txt. Now, if I list it out, I got 2 files. Great. And if I cat file1, it will say here are some words, okay? Now, what I'm going to do is I want to prove these two things are the same. I'm going to use the diff command, and it's going to be file.txt and file1.txt. Hit enter, and nothing comes up on the screen. Nothing comes on the screen that good. It means that they are the same, okay? Now, I'm going to echo the number 1, and I'm going to append it, not overwrite, append it into file1.txt, okay? Now let me go ahead and cat file1, and notice it says here are some words, and then there's another single character on another line called 1. Okay, wonderful. So what if I diff now, and you know what, I'm just going to up arrow right there, and you'll see 1 diffed with 2. There's a character over there. It says, hey, there's a number 1 that's different. Okay, so you see that there is a difference. Okay, wonderful. Now I'm going to moving down to right over here with the MD sum. So I'm going to do this MD5 sum of file.txt file, and I'm going to send that to a new file, and I'm just going to call it hash1. And it's basically going to be a plain text file. It's not going to have the txt, but it'll be treated like that in Linux. So, okay, it's there. And then what I'm going to do is I'm going to do the same thing. I'm going to go file1.txt, and I'm going to change that to hash2. Okay, so we now know that there's a difference between file1 and file2. We checked it out. And let me go ahead and ls real quick. You'll see I have file1, I have file1, hash1, and hash2. Now I want to diff hash1, hash2, and it shows you what the differences are. And let me go ahead and clear and do that one again. So I have my file text hash output, my file1 text hash output. This is the difference between the hashes, okay? Notice all I did was add a single character 1, and the hash is very, very different. And that's part of a good hash. Allows you to change one character, add a space, delete, whatever, another file, and get a distinctively different non-deterministic from the previous hash output. Okay, so that's good stuff. Now, how would I use this in the future? What you would do is, if you're going to go download a program from the web and it provides a hash of the file, what you would do is copy that hash into like a text file, download it into your system, download the file into your system, hash the file, so you create like a hash1. Your from the website hash would be hash2. You diff those two things. If they're the same, what it means is the hash that's on the website where you got the file from equals the actual hash of the file, so that if someone came and like altered the file but didn't alter the hash, you'd be able to tell a difference. Okay, so we're going to move on now to Lab 2 OpenSSL. Symmetric encryption. So I'm going to go ahead and clear out of that, and I can be lazy. This is one of the benefits of using Google Cloud Shell, is you can easily copy paste. Okay, so I've got that. I'm going to echo this is sensitive information into a file called secret.txt. Right, I do a quick L, I see secret.txt there. I'm not going to cat it, you know what's in it. Okay, fine, I'll cat it. And you look, this is sensitive information. Why do you make me do this? Okay, anyway, now I'm going to encrypt the file using PBKDF2, password-based key derivation function 2, with 100,000 iterations. And I'm going to use the secret text file, and the output's going to be secret.encrypted file name. Okay, and you'll see what happens when I enter this command. Okay, so there's my file, OpenSSL encryption. I'm going to use AES 256-bit cipher block chaining. I'm going to use a randomly generated salt that OpenSSL is going to create for me. I'm going to use the PBKDF2 password derivation function, which requires the iter option and 100,000 options. My input file is going to be secret.txt. Output's going to be secret.enc. Hit enter, and it's going to ask me for password. I'm going to make it simple. I'm going to go ITM431, enter. And it says do it again, ITM431, enter. And there you go. Now I'm going to list it. And notice I have secret enc. So let's cat secret enc. and it looks like gibberish, right? It's salted. It starts with salted. It has some junk in there. I don't know what that is. I know it's not the text file I had previously. So how should we decrypt the file? Okay. So again, I'm going to just go ahead and copy this fine little command right here. I'm going to hit Command V and just go through it. I'm going to open SSL encryption, but TAC D is for decryption. I'm going to use the same encryption algorithm, salted, PBKDF2, 100,000 iterations. Now the file is the secret.encrypted file. My output is going to be decrypted.txt. Hit enter. It's going to ask me for the password. That's the key we used for this. ITM431, hit enter, and list it. Now I have a new decrypted text file right there. So I'm going to come over here. I'm going to cat decrypted text, and this is sensitive information. So that is a very simple example of symmetric key encryption. The key I used, ITM431, was the same key I used to decrypt it. Isn't that awesome? So now, what are the discussion points? These things in yellow, you should probably understand those. And what does assault do in this process? What assault does is it provides a random number that is added to the particular input file, randomly generated number added to the input file, so that you can defeat rainbow tables. In other words, if someone could easily have hashed out ITM431, but if there was an assault in there, and they would just be easily match it just by looking at the hash codes. But because I have these assault, they would have to know that salt to do their hash tables. And creating a millions and millions of password rainbow table with millions and millions of individual salts would be too laborious, and you wouldn't do it. There's some different experiments in here. You can read the difference. What is the difference between 100,000 and 1,000,000 iterations for trade-offs between security and speed? Look at that. So we're going to go on to lab 3 next. I want to keep this moving. Okay, lab 3 is actually the hardest, longest, and requires 2 people to play. I am going to do that with 2 different cloud shells I have. I have my Hawaii EDU cloud shell, and I have my regular personal Gmail shell. How come I have a Hawaii EDU shell? I think we mentioned that earlier. I went ahead and enabled all the additional features in my account, but that's okay. I'm going to show you the 2 ways I'm doing this. One with the one I'm going to call the instructor, the other one called the student, but for you it's going to be 2 students. So we're just going to have to pick one person who is going to be doing the encryption and signing, and then you're going to do decryption and verification with the other person. Okay, so I'm going to go with the instructor one first. I guess I will come over here to my sa8@hawaii.edu if I can remember that. And first thing is, when you're in your cloud shell, actually let's just try TAC V, see if that works. Hit version. All right, there you go. Oh, no, that's not it. Control C out of that. Okay, great. GPG, TAC version will tell you if you have GPG installed. This is GNU, pretty good privacy. And that's all you need. So I'm going to go ahead and clear out of this. Again, I have aliases in there. And then same thing on my other one. I'm just going to go GPG, TAC version. And yep, looks like we're good to go. Okay, so it should be the same version since, just using Google Cloud Shell. So going back to my instructor one. First thing I think we're going to do here is generate a key and then move on. So GPG, TAC full, generate key. So I think you can do full gen key. It's the same thing. I'm just going to go with the defaults. Hit enter, hit enter, hit enter, and then yes. And I have a key that doesn't expire, 3072 bits. Okay, needs to construct a user ID, so I'm going to go instructor Sal, Do a little camel case there. I'm going to go SA8 at hawaii.edu, which is my address. No comment, just hit enter, hit O for OK, and I'm going to enter a key. I'm going to use ITM431 as my key. Yes, it's not long enough, I know, ITM431, that way I won't forget it. And, you know, it says we're going to generate random bits, and boom, we got a key. Okay, so at this point, I'm going to clear. I'm going to go GPG, list keys, and this will be my public keys. And then if I want my secret key, I will go secret, and it'll be my private key. Okay, so you'll see that the identification is the same here. This is the identification. The 26F ends with ACE. Same identification, but these are two separate keys. One is the public key, and it's in the list keys, and the other one is in the list secret keys. How can you tell? Let's not worry about that right now. Let's just say on the instructor tab right here. Now, I'm going to go ahead and I am going to copy this right here because I am lazy. I'm going to paste it in, and yeah, you gotta go and I'm just going to update my email address here. Everything else is going to be good. SA8 at hawaii.edu, and instead of instructor, I'm going to go SA8 underscore pub key as the name. Hit enter, and then let me just do a quick tree, and notice where it is. I've got the SA8 pub key.asc in this particular root directory. And if I wanted to move it, I could move it to the files directory, but I'm just going to keep it in there for now, and that is going to be my public key that I will upload to somewhere else. So let's say for now, I'm going to go back to my files here. I'm going to add and remove some attachments. You get to see how the sausage is made here. I'm going to remove that. I'm going to remove that, and I'm going to remove that. Okay, I'm leaving these two group pictures because that's a steganography we'll do later. Okay, now what I'm going to do is I'm going to go ahead and download, and I'm going to search for, the specific file, which is my SA8 pub key. Okay, hit download, and it's going to go to my downloads directory. I'm going to come over here, and I'm going to go to my downloads. I'm going to go to my pub key here. Don't worry about all those other ones. I was trying different things for this lab. Go ahead and hit continue. So now I got my SA8 pub key. Go ahead and save changes. And if I wanted to look, okay, that stuff is there, but it doesn't matter. Okay. Now, this was again on what is called the instructor. Now, on the student task, you're also going to, right here, let me get a tree real quick. See, I don't have a lot in here. I don't have files or anything like that. I'm just going to go straight from the root directory. I'm going to go GPG, full gen key, hit enter, and I'm going to go enter, 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 yes. And real name, it's going to be student Sal, okay? And email address, I'm just going to go sal@gmail.com. That is not my actual email address. You see it's sal.origem or whatever, but I don't want to deal with it. Typing all those letters out later. Hit enter, and hit OK. And I'm going to go with the same exact key, ITM431, because I'm only using this thing for the labs. Enter, plus you'd have to get my private key to do anything with it. Okay, so it's good, and then I'm going to clear real quick, and then I'll do GPG, list keys, And I have, what do I have there? So I have this old one that I'm not going to use right here at all. This is ITM431. I was playing around with one separately. This is the one that matters, a Sal at Gmail. So don't worry about that one. And if you want to, you don't have to do this, but you can go GPG, tag, delete, key, and you come over here and you copy that. You go ahead and hit enter, and there's a secret key for this. Okay, so it wants me to delete the secret key first, which I'm not going to use that one anymore, so I will delete it. It's going to say, are you sure? I'm going to go yes, yes, delete, delete. It's gone. Now I come back here, go ahead and delete the key, yes, and it's done. Now, if I GPG list keys, let me clear that again. GPG list keys, it's my Sal at Gmail, the one I just created. And then if I want to get my private key, I'll list secret keys. And you'll see I have one right there. Same for the private key. All right, so we're basically the same on both of these at this point, right? So I can just do a quick tree. Oops. And you'll see that, oh, where did it go? Oh, that's because I didn't do any exporting the key, so it didn't get there. So that's okay. Clear. Come over here. Clear again. Right now, I'm back on my student key, and I am going to export my public key. So I'll do a GPG armor. And I do recommend you go ahead and slap this command into Chat or Claude and ask it to describe what all the different options are, but I have a lot to do. So I'm not going to do that right now. And I'm going to do, I'm going to go Sal Gmail, pub key, .asc, and remember when you do 1 caret, it's basically overwriting or creating a new file. So go ahead and hit enter. Now do a tree again, and now I have my Sal Gmail pub key .asc. And just for shiggles, I want to see that again. I always forget the name of these things. So I got SA8 pub key. That's my public key for the instructor. Here's my Sal Gmail. It's a Sal student one. Okay, great. Now we're going to import the instructor's public key. So on my student one, I'm going to come over here. I'm going to go upload. And I'm going to choose a file. And I'm going to choose that SA8 pub key, which I just opened up earlier. And hit upload. And again, this is the magic and beauty of having this as opposed to SSHing files, which is very easy to do once you have the SSH connection set up, but otherwise it is kind of a pain in the butt. And now look what I have. I have SA8 pubkey.asc and Sal Gmail pubkey.asc. So I've got the instructor and my own public key here. Alrighty. So now let's go to encryption and decryption. So I'm on the student side, and I'm going to create a message. So I'm going to do this. I'm going to echo hello instructor gadget. I mean Sal. That's it. That's all you need. Okay. And I'm going to go boom secret message student.txt. Do a quick look. I can even cat the message, hello instructor Sal. And you don't have to put that. That's what I did because I can't think of anything right now. But working all day. Anyway, so now I have the secret message. And what I'm going to do next is I'm going to encrypt the message using the instructor's public key. So I'm going to go over here. I'm going to copy this. Hell with it. I'll just type it out. Okay. GPG encrypt. I'm going to use armor again, if you spell it right. I'm going to go tac recipient. And the instructor email here is sa8@hawaii.edu. Oops. And I have to use the email address of the public keys that I have. So I got Salad Gmail for my own, and I've got sa8@hawaii.edu. And then secret message student.txt. Then I'm going to hit enter. What? That is strange. Let's try that one more time. sa8@hawaii.edu, wkd, no data. That's crazy. GPG list keys. Oh, interesting. I never actually imported the key. I just downloaded it. How come you didn't catch that? Okay, so I come up here again. It said to import the key, right? So what I did was I didn't actually do this part. Now I'm going to come up here. I'm going to go GPG, tac import, and I'm going to go oh, this is why I need to do tree, sorry. Okay, GPG, tac import, sa8, public key.asc. This is what I need. Now, it says it's important. Now I can go GPG, tac list, tac keys. Now I see the sa8@hawaii.edu. All right, wonderful. Now I already have secret message. So let me go back to the command I had that failed earlier. I go ahead and hit enter, and notice what I have here. Do you want to use this key anyway? And now it says here it's not certain the key belongs to a person named because I'm not using a CA, certificate authority. I'm doing my own thing, but yes, use it anyway. Now let's tree again, and notice I have secret message student.txt.asc. All right, I'm going to clear out of that. All right, submit the encrypted file to the instructor via the LMS. So I will go ahead and I will download the key. Real time showing how it works. I'm not going to download the key. I am downloading the secret message student download. Then I'm going to come back over here, go back to my announcement, and I'm just uploading the files I'm using here. And I'm going to choose a file. I'm going to go to my downloads. I'm going to go to my, you get to see a whole bunch of stuff in here. Hopefully none of it is important. All right, hit continue. And there it is. I'm not even going to save this yet because I probably have to upload some more stuff. So just for now, that's fine. So then what I'm going to do is, okay, created this, created that, submit the encrypted file. The instructor will decrypt the message using their public key. So now what I'm going to do is I'm going to pop on over here, clear and tree again just to see. And what I'm going to do is I'm going to download that message, okay? Or actually I'm going to upload the message. Which message am I going to upload? It's that. That one right there, secret message TSC. Hit upload and then tree again. And you see that I have secret message student text.asc. Okay, so now I'm going to do GPG, tac decrypt, and secret message student.asc, hit enter, and I'm going to put in the password I used to unlock my secret key, ITM431, and there's the message right there. Now if you tried this and didn't have the private key, it would not work. So how does it know which key to use if you If you have multiple keys, excuse me, it's going to look for the key ID in the GPG key folders. That's how it's going to know what key, if you have a private key, to open it. Okay, so that gets down to here. Okay, let's go to digital signatures part. Okay, so where are we? Yeah, we're going to go back to student. So on the student, what we're going to do is create a text file. Echo, this is from student Sal to instructor Sal. Okay, and then I'm going to cat that out to student signed message.txt. Okay, so all I'm doing is I'm going to this first part right here, message to be signed. And again, I'm doing it from my student account. And I created my own private key and stuff earlier. So then it goes sign the message with your private key. I'm going to go GPG, tech, sign, tech, armor. And it's going to be student signed message.txt. And this is going to create, now I'm going to put in a passphrase. Now notice this is the passphrase from my private key that I created earlier. And because I wanted to not mess it up, I just used ITM431 for mine. Okay. Now tree that out again and look, I have student signed message txt.asc. And you go ahead and submit both the original and the signed message to the instructor. Excuse me. Now it's missing a point right here in the instructions, but we'll go through that real quick. Okay, so I am going to download 2 files. The 2 files are student signed message and download student signed message txt.asc download. So now those are both downloaded from the student. I'm going to go over to the instructor. I'm going to go ahead and upload, choose files. I'm going to choose, I don't know why it's doing it like this. I guess it's alphabetical. That's stupid. I'm going to go ahead and upload both to the home directory. Hit upload. Great. And I'm going to hit tree. And notice that I have student secret message .txt.asc and then student sign. Okay, student sign message right down here. There we go. Great. Clear that out. Now here's where the instructions might go awry, which I think they will. Okay, so I'm going to go GPG tech verify student.asc, hit enter, and it goes can't check signature, no public key. Why not? Because I never did on the instructor one this part up here where I go GPG import. Oh, sorry. Let me go to the tree again. So I have SA8 public key, but what I don't have is I don't have the public key for the student. So I go back to a student. I'm going to go ahead and download the public key for this student. So Sal Gmail public key, download. Okay, that you see, never did that part. Go back to my my instructor computer. I'm going to upload the Sal Gmail. Okay, hit upload. And then I'm going to GPG, tech. Oh, I'm going to tree first. Okay, clear, tree, GPG, tech import. And it's going to be Sal Gmail, Gmail public key. Boom, it's in there. Now I can go GPG, list keys, and I should have 2. So I've got my Sal Gmail, I got my instructor. Now I can go back to my verify student signed, and you come down here, good signature from student Sal. There's no indication that the signature has, you know what, let me do that at the top. Verify the message. Go ahead and you'll see here that it's a good signature from student Sal. Key is not certified from trusted signature, means it's not part of a CA. That's not a big deal. And there you go. And now once I know that the message is good, I can cat student signed message.txt, and I know that that message actually came. So I didn't encrypt this message from the student. What I did was I signed it and sent the plain text message back along with the signed message. Okay. So that is that. And that's kind of where we are. Going to move on to the next one. Okay, so I'm moving on to real quick one, password hashing. We've talked about hashing, it's in the book. We're going to use a open source command called OpenSSL, and we're going to do password, and we're going to do this command, and we're going to talk about what each and every component, random salt, hit enter, and here's where it's going to do password. So you're using the OpenSSL command, and it's for a password salting. Okay, so the -6, I believe, is SHA-256, which is SHA-512. I'm wrong. So -6 is the SHA-512 algorithm. So the password I'm going to put in there is ITM431. Hit enter, and then you get the output. So you have, I'm using SHA-512. I'm using the random salt as a word. Is this just, it's an arbitrary phrase called random salt. And then everything from the $ down is the actual salted password of ITM431 with a SHA-256 random salt as the primer for it. So there you go. So this OpenSSL command generates the hash password using a custom provided salt of random salt. Now, this is not what you would normally do in a program. You let OpenSSL do a random generation for it, but I just wanted to show you, you can salt something with your own word, but you will not want to use the same salt for more than one password. Each salt is supposed to be randomly generated, also unique to each password that you salt to make it hard for rainbow attacks to happen, right? So why is salting important? How's it protecting against rainbow attacks? So if I had a password of ITM431, super simple password to break. If you just hash that and you looked for the hash output of ITM431, I could just run a rainbow table, shawing 6 characters out, brute force. I'd very quickly find ITM431. But if I add a salt, then I would have to generate all those brute force password hashes with the salt on there. And if each password is different, then it would be very, very hard to make a rainbow table. And people wouldn't do it, which is kind of how it works out. Okay. So now that's it for number 4. We're going to go our last 2 here. Is this our last 2? Yep, it is. Our last 2, stag and random number generator. You know what? I'm going to go down to 6 first for the random generator, just because it's pretty easy. And here I'm going to do is I'm going to use this command. Go ahead and paste it in. And what does the head command do? It reads the beginning of an input. It normally reads by default the first 10, but in this particular case, you're reading the first 32 bytes. And then you're going to use the special Linux function called urandom that generates random data, and then the XXD just dumps it into hexadecimal. So you have 32 bytes of random data with dev urandom. And then you can also use OpenSSL, its own random function. And I want the output to be in hex, and I want, it says here 16, but I can do 32. hit enter, and there's a 32 byte randomly generated number that I could use as a salt instead of the word random salt. So why are random numbers so important to modern cryptographic systems? It's a great potential exam question that you should look up. I'm not going to tell you right now. I want you to do a little work. Okay, so let's go back to steg in lab 5. So I'm going to see right here. So let's go first, steg hide, tech version. See if it's in there. Okay, so steg hide is not installed. So I'm going to sudo apt install steg hide. Okay. Yes, I want to continue, and it goes ahead and does the installation, and it doesn't crap out, which is always nice. Now, the instructions here say go ahead and embed a secret and then extract the secret. Instead, what I want you to do is I want you to go to Laulima, and you know what, let me add one more attachment real quick. I want to add that other public key. Where is it? Sal Gmail public key, just so you can go back and see it. Continue and save changes. Okay, so if you look at the lab, I've got two files here, grusal and grusal. There's two different JPEG files. Let me see if I have them here. Nope, I don't have it there. Let me see if I have it underneath my instructor account. Yeah, I already downloaded these to my instructor account, and you can do it the same way I did everything else. You save it, you download it. I did it multiple times in this video. You should be able to figure it out by now. Okay, so here, since I'm on the instructor one, let me go steg hide tech version, and don't have it, so sudo apt install steg hide. Now, actually did install steg hide on here before, but the way the Cloud Shell works, sometimes it'll dump the packages and make you reinstall it, which is no big deal because we're just using it for lab purposes. Okay, so I'm going to go steg hide and extract and grew I'm sorry, tech sf. Oh, 1 second. Sorry, it's not auto-completing, so I got to type it. Okay, steg hide, extract, tech sf, and then grusal.jpg. Hit enter and enter a passphrase. So I probably used the tricky passphrase of like ITM431 and could not open the file. Okay, got it. So let's do grusal, and then we'll go space 1. And because it's a file name, you'll want to, and there's a space in there, you want to put it in quotes. It's going to ask you for the passphrase, ITM431, hit enter. Also couldn't open up the file. Interesting. Is it something stupid like I need to CD into files? Maybe. Now let's try it, and ITM431, and wrote extracted data to grusal.txt. So now if I T that, you'll see that I have a grusal.txt, which I didn't have before. What's in grusal.txt? That, my friend, is for you to figure out and open up and cat it yourself. Now I do want to come back here. I want to point out something. So I have two different GRU files. One of them has data, the other one doesn't. So let me see. Let's go back to here. And again, I don't know which one I downloaded in order, but it doesn't matter. It doesn't matter. I'm going to go ahead, hit enter. I'm going to go ITM431, hit enter. Could not extract any data with that passphrase. I probably typed it wrong. ITM431, Boom. Still couldn't extract any data with that passphrase. What does that mean? It means one of these two files has the secret attached and the other doesn't. But I want you to look at it. I want you to go ahead and click on Grusal. There's Grusal. Then I want you to click on the other Grusal. Boom. Those two files look almost identical, don't they? They do, but they're not the same file. They're different sizes. Which one is the one that has the secret data in it? You might think it was the 26K, and you might be right, but you also might be wrong, because all I'm doing is replacing pixels with some basic text. Anyway, figure it out, and you'll get the secret message. So we just went through everything. Did I number it properly? I did. So we just went through 1 through 6. By far the longest one is this lab 3 with the public key cryptography with GPG. I'm going to try to up these instructions to make sure you do things like import the key and stuff like that. But there's the video, and you should be able to watch it and go through all of this. If there is anything highlighted, like questions in here, and I don't have a question highlighted, but you can imagine a simple steganography question from it. These are questions that are fair game for you for the exam. Okay, if you have any questions, you know how to get a hold of me. Till next time, aloha.